Okay, hi everybody. This week, actually starting today and then this week, we are moving on to section 3, and we are going to talk about how to evaluate trig functions. That's essentially our goal by the end of the week. So for today, we're going to start off by talking about the definitions of our trig functions. So we're going to start with the unit circle, which fills me with such joy. You have no idea. But basically, a unit circle is simply a circle with a radius of 1. Okay, and this is the basis essentially for all of trig and all of our trig definitions. So we're going to start by drawing a circle. Hey, wow, look, that's pretty good for me. I'm so excited. Okay, so we've got our circle here. And again, the only thing that makes it the unit circle is that we're going to define the radius to have a length of 1. So I'm going to draw my coordinate plane on here. And let's suppose that I draw a point somewhere on the circle itself, and we're going to call that point XY. If I connect that point to the origin, right, then essentially I have created an angle in standard position, right? So if I'm starting here on the positive x-axis and rotating until I get to that ray that contains that point on my circle XY, then this angle here would just be my angle theta. And I know that since it's a unit circle, that the radius is equal to 1, okay? What I can do then is I can create a right triangle. So if I simply draw a vertical line to connect that point XY to the positive x-axis, essentially that angle theta is my reference angle, right? And so I can make a right triangle, and we should know the two legs of that right triangle, right? So if this point is XY, then that means that the length of this leg, would just have to be X, and the length of this leg would just have to be Y. Okay, so let's then use that triangle to define the 3 trig functions which you already know. Okay, so we know in general that we'll start with sine since it's SOHCAHTOA, right? So the sine of theta is opposite over hypotenuse, which in this case, my opposite side over my hypotenuse is just y over r, right, in general. But since it is the unit circle, it is just y over 1, which is just y. Okay, so all we're saying is that the sine of our angle theta is just equal to that y coordinate of that ordered pair, all right? The cosine of theta, by definition, we know is adjacent over hypotenuse, which is x over r. Since it's the unit circle and we know the radius is 1, cosine of theta is just x. So the sine of theta is just the y coordinate, cosine of theta is just the x coordinate. Fantastic, right? All right, what by definition is tangent? We know that the tangent of theta is opposite over adjacent. In this case, opposite over adjacent is just y over x. So just the y coordinate divided by the x coordinate is tangent. Okay, that's fantastic, right? There are actually 3 other trig functions, right? We know that now. So we have cosecant, secant, and cotangent. We know that cosecant is the reciprocal of which trig function? Cosecant is the reciprocal of sine, right? So we know that the cosecant of theta is just equal to 1 over sine, which we could define as 1 over y. The reciprocal of cosine is secant. So the secant of theta is 1 over cosine theta, or just 1 over x. And then our last one is the cotangent of theta. And cotangent of theta is 1 over tangent, which would make it the reciprocal of tangent, so x over y. Okay, so there's another way that we can define tangent and cotangent. So if we look at tangent and cotangent, notice that tangent and cotangent both are just x's and y's, right? Well, what did we already define, or what do we know x and y just represent? We already said that x represents the cosine of theta and y represents the sine of theta. So we could define both tangent and cotangent in terms of sine and cosine. So we could say that the tangent of theta, since it is y over x, is just sine over cosine. And cotangent of theta, think about it in two ways, right? We know that cotangent is just the reciprocal of tangent. So take the reciprocal of this, and we get cosine theta over sine theta. If we think of it in terms of our definition here, x over y, x is cosine, y is sine. So either way, we end up with the same thing. So these two ways of defining tangent and cotangent are going to be really, really useful as we move forward here. So definitely something to keep in mind, that we can always express tangent and cotangent in terms of sine and cosine. Okay? Okay, let's talk about where our trig functions then are positive and where they're negative. All right, so what happens if our angle terminates in the first quadrant? Well, if that angle theta is in the first quadrant, then we know both x and y are going to be positive, right? And if x and y are positive, then what do we know about all 6 of our trig functions? They are indeed all positive. Here's a great little way you can remember that. I'll label it as we go. But in the first quadrant, we know that all of our trig functions are positive. Okay, what happens if our angle terminates in the second quadrant? Well, if we're in the second quadrant, what do we know about our ordered pair? Our ordered pair is now negative x, y, right? So it's still the same x, y. It's just that since we're in the second quadrant, we move to the left. Our x is negative, we moved up, so our y is still positive. Well, if x is negative, what does that tell us? What has to be positive still in the second quadrant? So the only trig functions that are going to be positive in the second quadrant are those that involve only y, right? Because if x is negative and y is positive, and we do, for example, we find tangent, well, if we had a positive divided by a negative, then that's going to be negative. So in the second quadrant, only those trig functions that involve only y are going to be positive. So that would be sine and its reciprocal. So sine and cosecant are positive. All right, how about in the third? So what's going to be positive in the third quadrant? I'm going to give you a second to think about that. What is positive in the third quadrant? All right, so if you said tangent and cotangent are positive in the third quadrant, then you are correct. All right, why is that true? Well, that's true because what's true of x and y in the third quadrant? Both x and y are negative, and if we divide a negative by a negative, then obviously it's going to become positive. All right, and then fourth quadrant, well, we only have 2 left, so that makes it pretty simple. But again, let's think about y. In the fourth quadrant, we know x is positive and y is negative. So only those that involve x will be positive. So that would be cosine and its reciprocal, secant, are positive. So everything else is negative. So here's the little, I know there's a fancy word for that, but you know me, I'm not an English person, so I don't know what it is. A fancy way to remember it. Notice I made these capital. All students take calculus. So A stands for all trig functions, S stands for sine and its reciprocal, T stands for tangent and cotangent, and C stands for cosine and secant. So all students take calculus is a way to help you remember which trig functions are positive and which ones are negative in certain quadrants. Okay, so hopefully you're with me so far. Now we're going to take all of this and we're going to put that together with what we know from geometry about our special right triangles. Okay, so in geometry you have 2 special right triangles, right? You have a 45, 45, 90, and you have a 30, 60, 90 triangle. Let's just refresh your memory real quick about those. If you don't remember, obviously, I think this one is pretty simple. Oh my gosh, that's the worst triangle I've ever drawn in my life. All right, probably not. Who am I kidding? But it's pretty bad. So let's say these are 2 45-degree angles. Oh gosh, that's awful. And let's say the leg of the triangle is x. Okay, if that's true, then we know that this leg of the triangle must also be x, right? And then what's the length of the hypotenuse? So hopefully you remember your relationships between the sides of a 45, 45, 90. So we know that that hypotenuse is just x root 2. And then for a 30, 60, 90 triangle, let's suppose this is my 30-degree angle, this is my 60-degree angle. So I know my short leg is x, right? And I know this is the short leg because it's opposite the smallest angle. We know that the hypotenuse is 2 times the short leg, so that's 2x. And then the long leg is the short leg times root 3. Okay, so we'll keep that in mind as we continue on here. So now what we're going to do is we're going to go back to our unit circle. So I'm going to draw another, oh boy, another unit circle. We're going to use our imaginations and pretend. And let's pretend that I have a point here, which will be point A. And let's suppose that I want to figure out what the coordinates of this point A are if I have a 45, 45, 90 triangle that I'm going to draw in here. So let's say that this triangle here, so this angle is a 45-degree angle. This is a unit circle, so the radius is 1. And I want to know what are the coordinates of this point A. Okay, so if I know that this is a unit circle and the radius is 1, we could use this information from our 45, 45, 90 triangle in order to figure out the length of the 2 legs, right? If we know the hypotenuse, how do we find the leg? So what did we do to the hypotenuse to get this leg? Well, if we know the leg, to get the hypotenuse, we multiply by root 2, right? So if we're going in the opposite direction, then we want to divide the hypotenuse by root 2. So that would mean that this side x would have to be 1 over root 2, which if we rationalize, becomes root 2 over 2, right? Okay, so that's my x coordinate is root 2 over 2. What does my y coordinate have to be? Well, since it's a 45, 45, 90, they have to be the same, right? So the coordinates of that point A are going to be root 2 over 2, root 2 over 2. Okay? All right, let's do the same thing for a 30, 60, 90 triangle. So let's say this is point B now, and I'm going to make my triangle, right triangle, again, unit circle. Radius is 1, so the hypotenuse of my right triangle is 1. And let's suppose this time that my angle theta is 30 degrees. And we want to find the coordinates of B. All right, so this is the, let's label this. This is x and y, right? So we know that the hypotenuse is 1, since that's the radius of the circle. If we know the hypotenuse, easiest thing to do first is to find the short leg, right? Because if we know the hypotenuse, then the short leg is just half of that. So if the hypotenuse is 1, then I know my short leg, which is y, since it's opposite the 30-degree angle, has to be half of that, so y is 1/2. And then once we know the short leg, all we have to do is multiply it by root 3 in order to get the long leg. So that means that my long leg is just the short leg, which is 1/2 times root 3. So that becomes root 3 over 2. So my ordered pair then is root 3 over 2, 1/2. And that's when my angle is, my reference angle is 30 degrees. Here, my ordered pair was when my angle was 45 degrees. Okay, we've got one more though, right? Because I could take this 30, 60, 90 triangle and I could switch where the 30 degree angle and 60 degree angles are, right? Well, my circles are getting better and better. So let's say this is point C now. And I'm going to draw my right triangle again. And my circle is still a unit circle. This angle is now 60, and this one then would have to be 30. All right, what's the only difference then? How does this triangle different than the one that we did up here? All that does is take my x and y and switch them, right? So that means that my x coordinate now is the short leg, which is half of the hypotenuse, and my y is the long leg, so root 3 times the short leg. Okay, so if you know this, you know everything you need to do everything else that we're going to do in terms of the unit circle and evaluating trig functions, okay? I posted a blank unit circle in your folder this week. I'm going to put it up here so you can see it real quick and then tell you what I want you to do with it. Okay, so the unit circle looks something like this in all its beauty, right? Isn't that lovely? So you could go in and we could fill in all of these angles in both degrees and radians, and then give the ordered pair that corresponds to that particular angle if we think in terms of the triangles that we just drew. So for example, this first angle would have to be 30 degrees, right? I'll put one that has some information in it up, but I just want to talk it through before you see it all. So this angle would be 30 degrees, this would be 45, and then this one would be 60, right? Now let's think, what's the equivalent in radian measure? So the equivalent of 30 degrees would be pi over 6, right? The equivalent of 45 degrees in radians is pi over 4, and then 60 degrees we know is pi over 3. Okay, so what are the coordinates? Well, we just did those 3 coordinates, right? So we know what those are. So we should be able to use symmetry, I can't talk, in order to complete the rest of the triangle, or the rest of the unit circle. So let me just show you what the first quadrant here looks like, and then we'll talk our way through a little bit more. Okay, so we know this much, right? Again, 30 degrees, we know that 90 degrees here is pi over 2, right? A third of that is 30 degrees, so it has to be pi over 6. And we figured all those out before, earlier in the chapter, right? Again, that was the part that you were going to stick in your brain and not forget these angles, right? The equivalent of radians and degrees. And you have a formula to convert them, but you're going to make your life a whole lot easier if you don't have to do that every time. And then these are just the 3 ordered pairs that we just calculated, right? Or that we just came up with when we looked at our special right triangles. Keep in mind, here's something that helps me. Whether it helps you or not, I don't know, but I'm going to tell you. So if you know this first quadrant, as well as all the angles that fall on an axis. So obviously this point, if this is a unit circle, is 0, 1, right? At 90 degrees. At 0, 0, or I'm sorry, at 0 degrees, our point would be 1, 0. All right, and so on. So and these are called quadrantal angles. So if you know the ordered pairs for the quadrantal angles, as well as the first quadrant, that's all you need to know. You don't need to memorize the entire unit circle. I promise you, please, I beg of you, people are going to do it. But it's so much easier if you don't try and stick all that into your brain, okay? But here's the way I remember the ordered pairs, because obviously you could draw them real quick and figure them out. But I always think if you look at the angles in degrees and then in radians, a 3 and a 6 go together. So 60 degrees is pi over 3, 30 degrees is pi over 6. So 1, 3, 1, 6 for both of them. And then I always remember which ordered pair, because it gets confusing, right? Which one goes which way. That 30 degrees has to match root 3. So the 30 degree angle has the 3 first, and then the 60 degree just has to be the switch the X and the Y there, okay? Okay, so what I want you to do is take a look at your unit circle and the blank one that I've posted, and see if you can complete the rest of it using symmetry, okay? And then once you do that, obviously there's tons of unit circles you could just look up. I will post the completed one later in the week, not right away on Monday, just so that you think, or else you at least have to Google it to maybe try a little bit harder. But really try and think and use symmetry to try and figure out the rest of those angles and ordered pairs. And again, try not to use the formula for converting from degrees to radians, right? See if you can do it in another way without using that conversion formula. But you should, with a little bit of thought, be able to fill in that entire unit circle, okay? So for the practice to go along with this, you're really just going to be looking at where are things positive and negative, so in which quadrants, okay? And really concentrating on trying to understand the relationship that we have here in the unit circle. Oh, and then one more example that I'm going to do just to show you something else real quick. And then later in the week, we'll get to how to evaluate trig functions at any of those special angles on the unit circle. But let's say in the meantime, before we do that I gave you a point, all right? And this is not going to be a unit circle, but let's suppose that I gave you a point. This is really simple, that's why I'm gonna just stick this in here. And said that the terminal side, so let's say that the terminal side of an angle And again, this is always in standard position, right? So the terminal side of an angle passes through, I don't know, let's just choose a point. How about -4, 2? And we want to determine the value of all 6 of the trig functions. Okay, so what's the first thing we're going to do? Well, the first thing I'm going to do is draw it. So I have a point at -4, 2, so let's say that's somewhere here, right? So if I have this as my terminal side, right? So this is the point -4, 2, and the terminal side of that angle has to pass through that point. And if it's in standard position, that means the angle started here, right? So this is my angle theta. And what I want to do is I want to figure out what is the sine of theta, what is the cosine of theta, what is the tangent of theta, what is the cotangent of theta, what is the cosecant of theta, and what is the secant of theta. Okay, so if we think in terms of a reference angle, what is my reference angle? Well, the reference angle has to be this angle here, right? And the angle or the trig function of this original angle theta is the same as the trig function of this reference angle, except for perhaps the sign, S-I-G-N, right? Is it positive or negative? So thinking about which quadrant it falls in. So I'm going to make my right triangle so that this angle of the triangle is my reference angle. Right now, I know the length of this side of the triangle has to be 4, and the length of this leg of the triangle is 2, right? Okay, now, what I'm not going to do is I'm not going to worry about the negatives, and you can. For me, it's easier to just think about what quadrant I'm in and then determine whether it's positive or negative. If you want to use the negative and the definitions, it's fine too, but I think when you watch me do it, you'll see. If not, you'll do it your own way and life will be fine. So the first thing we need to figure out is what? We need to figure out the length of the hypotenuse, right? So since it's a right triangle, we could use Pythagorean theorem, right? So we know that 2 squared plus 4 squared is equal to r squared. All right, so r squared is 20, which means that r is 2√5. We are going to simplify our radical. Okay, so I know the hypotenuse of my triangle then is 2√5. Okay, now what's the sine of our angle theta? Well, the sine, if we're looking at the triangle, we know sine is opposite over hypotenuse, right? So the sine, is 2 over 2√5, which is just 1 over √5, which if we rationalize is √5 over 5. Is that going to be positive or negative? Since we are in the second quadrant, we know that sine is positive, so we're just left with √5 over 5. Let's do its reciprocal first. So what's the reciprocal of sine? The reciprocal of sine is cosecant, right? I'm going to use this version because then I don't have to worry about rationalizing again. If I take the reciprocal of 1 over √5, then that is just √5 over 1, or just √5. Obviously, still positive, right? Since sine and its reciprocal are positive in the second. Okay, now let's find the cosine of theta. We know that the cosine of theta is adjacent over hypotenuse. So that would be 4 over 2√5, which is 2 over √5, which if we rationalize is 2√5 over 5. All right, but we are in the second quadrant, and what do we know about cosine in the second quadrant? It is negative. Okay, what's the reciprocal of cosine? The reciprocal of cosine is secant. So again, I'm going to take the reciprocal here so that we get negative √5 over 2. Guess I should put the negative in there somewhere so that we know. Okay, and then lastly, we have tangent. We know that tangent is opposite over adjacent. So tangent is 2/4. We are in the second quadrant. We know tangent is negative. So the tangent, of theta is -1/2, which makes the cotangent of theta the reciprocal, so just -2. Okay, Okay, so two things. You're going to look at completing that unit circle using symmetry and really focusing on the relationships within those triangles, those angles, a connection between the angles and the ordered pairs. And then you're going to complete the assignment, again, that's related to positive, negative, and completing something like we just did here where it is not a unit circle. And then our next lesson this week, we're going to talk about how do we evaluate trig functions on the unit circle itself, okay? So we will have a Zoom this week if you have questions. Otherwise, feel free to email me anytime if you need something else. And I hope you guys have a great day today.